Okay, so what I wanted to do is derive the equation that you use to calculate your monthly payment of a mortgage or any loan that's compounded over a certain amount of intervals. In this case, we have the monthly period here, M, so that's going to be equal to our, what we're going to just call that our monthly payment. So we have that monthly payment, or right? And this part right here, that's going to be equal to, we just call that our principal. Our principal, that's the amount of money owing. Now, R is the annual interest rate. And I was going to be equal to, since we're compounding every month, every 1 month of the year, that's going to be R divided by 12. That's what, so if you have like 5%, you'll have that 5% divided by 12 to give you what you should have for I. And then we have this thing here, which is just a, let's see, here we have N, which is a number of months, number of payments per period, per loan period, per the whole loan. So like in a 30-year, you have 360 payments, okay? So given that, how would we derive it from scratch? Because I know a lot of people know how to plug it into a computer or a calculator, but I thought you'd like to see it from scratch, which is something that you can learn, and also learn how to modify. Supposing, for example, that you have a balloon payment. Well, that's pretty easy to modify in once you understand the principle. So let's start. So first I'm going to start with what I'm calling the first amount that you owe, in the first month that you owe. You really owe the entire amount of the principal. So that's when the amount owed is the same as the amount lent to you, because it's the first month. So what happens is that at the next pay period that you need to make a payment, then you have, that's going to be equal to A sub naught, whatever you owed there, right? Plus I times A sub naught minus a monthly payment. And this thing can be written as 1 plus I. You see, I'm factoring out an A sub O, right, minus that payment. So now you have this guy here that we've said A sub O is equal to P, right? So now I'm going to go like this and swap out this guy, and instead I'm going to have to put, another way of writing A sub 1. So I can finally write A sub 1 in the form of, with the P. So I can write that 1 plus I raised to the P minus M, right? So this, let's put a little green box around there, because that's going to be used to substitute later down the road. That's how much we owe at the end of the second month. Okay, now following that same kind of logic, we can see that we can start the same thing here, right? We can calculate A2. How much you owe on A2 is equal to how much you have still owing in A1. That's a 1. Plus the interest times how much is still owing, minus the payment for that month, where M is the monthly payment. Okay, so now I know that A2 can be written as 1 plus I, see, times A1 minus M. Now, we could see that, the reason that you can pull out this is because in all of these cases, if you distribute it back in, you would get what you had before, right? If you took this and distributed it back in, you'd get back to where you were. So now I see that A1, I could take A1 here and put it into here. Okay? So now I'm going to rewrite A2, and A2 is going to be equal to I'm just rewriting it equal to 1 plus I, right? But now I'm going to put what A2 is. I'll do that in green and I'll put it in a bracket. So A2 is equal to right here 1 plus I times P minus M. See, this whole thing here is equal to A1, right? And then we have minus M for that payment, right? Now what I'm going to do is distribute this guy through to here and then through to here, so that I have another way of writing A2 will be equal to 1 plus I. I have 2 copies of that times P minus M times 1 copy of this, see, minus M. Well, that looks like, quadratic. I think I'll put the P over here just to be a little more consistent. So what I'll do is I'll just swap the P with the paragraph. So I'll call this P times 1 plus I. And that was squared, right? So you can see what's going to happen if it's the same idea. I have A sub 3, right? But A sub 3 is equal to whatever you owed on A2 minus a plus I times how much we're owing still in A2 minus that monthly payment. So that means A3 can be written as, you can factor out the A2, 1 plus I equals A2 minus M. See that? Now, I got a whole new way of talking about A2 in terms of the principal and the monthly payment. See, here's P. So I'm going to take A2 and I'm going to stuff it up the A2. So now I'm going to write A3. A3 equals 1 plus I. Now, I'm going to put in what A2 is. So I'll put a red bracket here, and it's P times 1 plus I squared minus M times 1 plus I minus M, close the parentheses, and we still have then over here the minus B. Okay, minus M, sorry. So now I'm going to distribute this through, okay? And I'll distribute over here and distribute. You begin to see a pattern that A3 can be written as, so we got P times 1 plus I raised to the 3rd power, right? Minus M times 1 plus I raised to the 2 minus M to the 1 plus I, right? And then we have minus M. Okay, so that looks pretty good. Now all we have to do is start to look for a pattern here. So if we go with a pattern and we go down to our A sub nth payment, whatever, we want to know how much we owe at a certain payment. If you make all 360 payments, say 60, then A sub n is the last payoff. So, but we can see how this is going. This is becoming and following a pattern taking P. And whatever n is, it goes here, you see. And here I raise it to the n. Because you see the 3 with the 3, and the 2 up here with the 2 up here. See how it's going in a pattern? So what happens next is I'm going to write like this, and this is going to be end up being 1 plus I times n minus 1. See, 1 less than that, that's a 2, right? And then we have m, and then we're going to have a 1 plus I, and that's going to be just up to the n minus 2. And now we have minus dot dot dot, means we keep going until this n minus 2 goes to 0, and we're left only with the last payment here. See? So now we got something kind of generates a pattern. So let's take a look at that and see if we can come up with the equation that we want to, namely this one that we have over here. Okay, so I'm going to get rid of some stuff here because there's no more room. So I don't need any of this, I think. Get rid of all that. That's the nice thing about getting rid of ones and zeros. So the annual interest rate is the annual rate divided by 12. And all I really need is this bottom equation, right? Because I finally got something that's more general, but I showed you how you derive it. Okay, now, with this guy up here, so really I'm going to take this guy here. So now we're back down to this equation down here, which is the nth amount owed after n amount of payments, right? Equals to that. Now, I have to try to manipulate that because I'm trying to get from here all over back up here to this side of the corner. In other words, I'm trying to derive this from here, from this equation. Okay, now to do that, I'm going to factor out an m. You see that there's an m all the way through here. So I'm going to start with that. So I'm going to go over here and I'm going to rewrite this problem up here. The nth payment is going to be P, you see that, times 1 plus I raised to the n, yeah? And this then I'm going to take out, factor out a minus m, and that's going to leave me inside. You can see what's going to happen here. I'm just going to have 1 plus, well, I'm going to turn this around, so I'm going to pull out m, but I'm going to put this side first. So what I'm going to do is I'm going to take this and I'm going to rewrite the last term, which is m. See it? I'm going to write this last term, m, as the first term here, but I already factored it out, so it'd be a 1, right? And now all of these will be plus because I subtracted I pulled out a minus 1. So I have plus, right? And then I'll have 1 plus I raised to the 1, and then 1 plus I raised to the 2 plus, and then dot, 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 plus. Now you can see my last term right here is n minus 1 term. So that's going to be 1 plus I raised to the, here we have n minus 1. Okay. So now I'm going to close this bracket because that's another way of what that means, this m, right? So I've written this same thing here, but in another way I just factored out the m. Okay. Now let's take a look at this part of the equation here because this is interesting. This looks like a geometric progression because the difference between 1 and 1 plus I is a product of, you multiply 1 times I, right? And over here, to get from here to here, again, you're just multiplying times 1 plus I. So every movement is another multiplication of 1 plus I, you see, all the way down the road. So when you have that kind of situation, then you know that it's a geometric isolation. Okay, hold on 1 second here. Yeah, hello? Hey. Oh, good. I just finished up with class. Yeah. What's new?
I just want to know if Manuelito decided to, is he going to sign up?
Yeah, you already did.
Oh, good.
Mm-hmm. Yeah, that'd be fun.
I think he'll like it.
Yeah, I do too. I think he'll like it a lot. I'm not sure. Have to find something to do with the other one.
Oh, Ramses.
Yeah. Let's see what I can entertain him with. I don't either. Oh, he's doing well in school and everything, but he's always a little harder, yeah. But I'll figure out something to do with him. I don't know. Yeah. All right. That's the case. So under here, I noticed that in red we have a geometric progression. Let's let R here, just to make it simple, let's let R equal to 1 plus I. Okay, so what's in red I can write as sum of, I'm going to sum now. This is going to be what's in red. I got a 1. I got a 1 plus I. I got a 1 plus I squared dot, 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 plus. The last term is 1 plus I raised to the n minus 1. Okay, now I'm going to do a little trick here so I can compress everything that's in red into a single smaller equation. I'm going to take r, and then I'm going to multiply it times the same sun, yes? So if I take r and multiply it times 1, you can see, so now I have 1, so I'll have, well, remember I was going to let these be r, so let me get rid of this because I didn't, and I'm rewriting it because that was equal to p times 1 plus I raised to the, that's going to be raised to the n, right? And then I had minus m, and then I had everything written in reverse. I have 1 plus I plus 1 plus I squared plus dot 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 plus the last term, as you can see, is 1 plus I raised to the n minus 1. Okay, looking at that part there, then, and I said let's make a substitution. Let r equal, 1 plus I. So I can call that sum. I'm going to sum them up. The sum of these terms here. But I'm going to write them in terms of r now, right? So I have 1 plus r. Notice that r times r would give me an r squared and r3 plus dot 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 plus r to the n minus 1, you see? Now, if I take that same number and I multiply it times r, times the same sum, you see? So then I have r times 1. You can see that would be r, and I'll put it under this one. And then I have plus, then I have r squared, right? And then a plus r cubed plus dot 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 plus r to the n minus 1. And then we have one more, because r to the 1 power would be r to the n. Now if I take this line here and I subtract, so I subtract this from this, so all of these things turn minus, and then I add them up so that I have s of n minus r times s of n is going to be, the only thing left will be this 1 minus the very last term, r to the n. You see that? So now here I can actually factor out the sum, leaving me 1 minus r, you see? And that's equal to 1 minus r to the n. So what I can do there is just solving for the summation of the geometric series. I can rewrite it in short as r to the n over 1 minus r. Now, you can actually turn this around by multiplying minus 1 times divided by minus 1 down here, so that just rewrites this form as Sn is equal to r to the n, minus 1 divided by r minus 1, you see? So what I'm saying now is that I can substitute back this, right? So I can write s of n in terms of 1 plus I raised to the n minus 1, yes, all over, that guy, right, as divided by this r minus 1. Okay, so, well, anyway, we got to replace what this is, right? I'm replacing r. And what am I replacing it with? I'm replacing it with I plus 1, you see? I plus 1 minus 1. So that this guy is going to be equal to, finally, 1 plus I raised to the n minus 1 divided by just I, right? Because you have plus I minus I. So now I can rewrite my top equation, the blue equation, as a sub n, right, equals p times 1 plus I raised to the n minus now m. Now, instead of what's in the equation here, I'm going to put this new compressed way of writing this thing out. I'm going to write it here, which just simply means 1 plus I raised to the n minus 1, right, all over. Just down here we have I. You see that? Now, suppose that we have in our final payment, let's say the n is equal to 360. That's our last payment. Well, you would expect that, the last payment, then the difference between this and this is going to be equal to 0. Because after we make our 30th, 360 payments. We no longer own any principal. So we have principal times 1 plus I minus m times, in parentheses, 1 plus I raised to the n minus 1 over I. Now, just using algebra, I can bring this whole term here over to the other side. So that what I would have when I bring it out over to this side, I'll have just m. And I'm trying to solve for m, right? That's my monthly payment. M is equal to, and this time it's positive, 1 plus I raised to the n, yes, minus 1. Sorry, that's not minus 1, that's minus I. Okay. That's that type. And that's going to be equal to what's left over here on this side is just P times 1 plus I. Yeah, raised to the n. Right? So now if I multiply by the reciprocal of this, then I can finally get m by itself. M will be equal, now this I will come to the top, so I have P times I times 1 plus I to the n all over, and then this bottom part, because it flipped now, this is 1 plus I to the n minus 1. And that's the famous equation for calculating your, oh, sorry, this is not 2. Let me get rid of this. This is not 2. This is n. And this is what I wanted to show. So you can try it out. You know, say you have 100,000 principal, 5%, and 360 payments, and you'll figure out what your payment is. You can also solve for n if you want to. If you know your payment and you know the rest, you want to solve for n, you're going to have to use some logarithms to get that down. Okay, now you can see if you're not at your a sub nth term and you're before the last term, well then a sub n can be considered, the nth term could be considered your balloon payment. And we'll go over that next time.